Welcome to Chapter 8 of Business Statistics. You're going to find that we're going to, downsize Chapter 8 considerably for what we're going to take forward in class. There's a lot of activities in Chapter 8 that you'll have access to know about and reference back to when in the business world you need to go back and determine how to accomplish the tasks so assigned. As you recall, in Chapter 7, we dealt with a couple of things primarily. One was dealing with a confidence interval with both large and small sample sizes. How do we accomplish that? How large a sample do we need? And then we looked at establishing a basic sample size with confidence levels and with standard deviations. Moving forward to Chapter 3, it covers a number of things. We're talking about taking a total population and taking a portion of that population. And in some cases, later in the chapter, we're taking a couple of different population proportions out of that total population and starting to compare one to the other. We're looking at, again, continuing to build interval confidences. We're going to look at sampling distribution of the sample proportion. What's the probability distribution of all possible values of the sample proportion when a random sample of size is taken from a given population? We're going to look at determining sample size with and without pi. We're going to learn a little bit more about pi. Using the sampling distribution to build a confidence level. Again, with and without a standard error rate. Sometimes an acceptable error rate can be looked at, and that becomes a part of the confidence level, confidence interval that we're going to be looking at. So, a sampling distribution of the sample proportion is the probability distribution of all possible values of the sample proportion. We're going to refer to sample proportion as p-bar. When a sample of the size n is taken from a particular total population. So, predictable sampling distribution properties. Let's look at that central theorem or limit theorem. What does that mean? It's a quiz question, I'll point that out. But the central limit theorem, as sample size increases, the sampling distribution of the sample mean rapidly approaches the bell shape of a normal distribution, regardless of the shape of the parent. Couple of items to remember from this particular slide. First of all, p-bar refers to the sample proportion. We've pulled a part or a number, a quantity, out of the total population. That's the sample proportion or p-bar. Pi does not represent 3.1416. Pi we're going to use in statistics representing a population proportion percentage. And we'll talk to how we do that shortly. So predictable sampling distribution properties. The sample size is a relatively small fraction, less than 5% of the population. The standard deviation or standard error of the sampling distribution can be computed as above. Now keep in mind, if you go back to Chapter 7, that finite population correction that we applied, we're going to continue to use that in Chapter 8. That confidence interval, what is that? P-bar, what was that again? Population proportion, plus or minus z. Z equals what? We look at standard deviations, don't we? 1, 2, or 3, 1.95, 1.99. Well, you remember the numbers probably better than I for 1, 2, and 3 standard deviations. But we go to the z-charts where we determine what we're going to use. And then the rest of the formula. Pi, if we're given pi, and we'll learn in a second what that is, times 1 minus pi divided by the sample size, the square root of that times the z-score, the 1.95, whatever that turns out to be. We'll talk about an example. We're going to use the healthcare example. We're going to look at an estimation of a population proportion. The uncertainty about the future of healthcare in the U.S., nothing ever changes, does it? Is a source of anxiety for many people across the country. In a recent phone survey of 750 randomly selected Americans, 600 of the people contacted indicate that this issue was a serious personal concern. You're going to build a 95% confidence interval estimate of the proportion of the population. Now, how do we do that? Going back to that formula, P, and how do we determine P? We look at our total sample size divided into the number of people that were concerned. So that's 600 divided by 750. That's 80%. We're looking at a 95% confidence level, and if we go back to the Z, if we go to the Z tables, we remember that 95% represents 1.96 Z-score, and then we put it through the formula, 80% times 1 minus 0.80%, or 80% times 20% divided by 750, that was the sample size, gives us our interval. So we can be 95% confidence that the interval plus and minus 80%, 80% plus or minus 0.0286 contains the proportion of all Americans whom in the future are concerned about their health care. So determining sample size. If we want to look at that, how do we do that? Or we want to determine what an error rate we should be looking at. Here's the formulas for that. You remember the sample size formula from before? N equals your z-score times 0.2 times 0.8 divided by the error rate that we've predetermined. Square that, gives a sample. So, in a healthcare survey, suppose you had to ensure that 95% probability that the sample proportion you produce will be within 1%. How large a sample would you have to have? 95% confidence level. We're going to look at what is N. Putting in the formula, the error rate can only be 1%. That's a small percentage of error. So we're going to have to sample 6,146 people. Change that to pi equaling 0.5 if we don't have p-bar. Put 0.5 times 0.5, the square root of that, it changes that number considerably larger to 9603. Not having p-bar is always going to raise the quantity of the sample size that you're going to have to work with. That really concludes the part of Chapter 8 that we're going to work on in class. I'm going to ask that you read through the chapter, understand what the rest of the activities are. It's dealing with confidence levels of established probability and error rates, difference between two population means, difference between two population proportions, different quantities, different samples being pulled out of a total population. Best of luck.